Good afternoon, everyone. First of all, let me show my intense admiration to those of you who lasted this long, hearing talks the whole day. It's challenging, and Loris also set me a high challenge. He tried to convince you guys why Zig is the way to write Redis modules and why Rust is extremely complicated with a borrow checker. So, of course, he's right. But still, I'm going to try to convince you that writing Redis modules in Rust might be a good idea after all. What is Rust? We'll first talk a bit about what Rust actually is, which Loris didn't get into. Then I'll talk about why Rust. Why do I think personally that Rust is a great idea for writing Redis modules? Then we'll see a bit of Rust syntax. You can't diss something without first seeing how it looks like, right? And finally, I'll show you the work I've been doing at Redis Labs as a side project for creating a toolkit to easily write Redis modules in Rust, so you don't have to do all the hard work yourselves. So Rust is blazingly fast, memory efficient, and safe. The platonic ideal of programming languages, right? So I'm still in the infatuation phase, as you can see. I started learning Rust a few months ago. I think it's a wonderful language. It's not an easy language. Loris was absolutely right. Zig might be easy when you come from C. Rust is not easy. You will fight with it. But this is one of the fights which actually makes you stronger, because you learn a lot about how to organize your code. Most of the mistakes I made in Rust when I learned it, and most of the mistakes I heard from others who learned Rust and who studied it from all kinds of different angles and wrote blog posts, is people try to write Rust as if it is C. Same happens with Java guys or Python guys when they learn a new language. They try to write code in a new language as if it is their previous language. And that doesn't work. If you try to write Rust code as if it's C, first of all, why? I mean, why write in Rust if you want to write C? And secondly, you're going to fight with it and it's going to hurt. So once you understand the good things that Rust can give you, you start to fall in love, and you might stay in love, you might get divorced, but still, I think it's a great thing yet. So Rust has a friendly compiler. Unlike some programming languages starting with the word C and having some plus symbols after it, it's possible to understand if something doesn't compile, what happened. You don't have to wade through pages and pages of error messages to try to understand why your template, sorry, didn't say anything, it doesn't work. So Rust, the compiler tries to help you. If something doesn't work, it shows you a diagram, it shows you your code, it shows you what doesn't help, what doesn't work. It gives you some suggestions on what you might have meant, on which syntax you could use instead. It's amazing. It's an amazing learning tool. And it has Cargo. Cargo is the build tool for Rust. It's also the package management tool, and it's a version management tool. So Cargo builds your code. If somebody has used Go, it's very easy to just to do Go build. It's the same thing with Rust. You say Cargo build, it automatically does whatever is needed. It collects the dependencies, uses semantic versioning. It's a fantastic, fantastic package management tool. It's very easy to use. So why use Rust for writing Redis modules? Redis modules run in the same memory space as Redis. This is something that's sacred, memory space. If you crash Redis because you do an incorrect memory access, Redis is gone. You crash your server. We don't want anybody to easily be able to do that. If we would just want to write a small module to do something, or even a big module to do something, we would like that module to be safe. We also don't want to leak memory, so we need a language that lets us manage memory very carefully. Rust doesn't use garbage collection. Garbage collection is an easy way to get memory leaks, and also an easy way to get unknown delays and hold-ups, stop-the-world stuff. Yeah, the Go guy says that that's not a problem, but I think it is. If you were in a data path and if you want to give sub-millisecond latency as Redis does, it is a problem to use a garbage-collected language. So Redis is also mostly single-threaded, as you know. So if we hold up our module, we hold up the entire Redis process. So we don't want to do that. So Rust safety does not mean reduced performance. As they say, we can have nice things. So who here has ever programmed in C? Who here likes programming in C? Okay. So I actually like C. I think C is a great little language. It's a little language. It's simple, it's small, it's easy to write a compiler for it, it's easy to implement it. It's also very easy to access memory directly. That's the whole point of C. It's a portable assembler. It was meant to write operating systems. The Unix was written originally in assembler but imported to C. So it's very easy to access memory. You have raw pointers, pointer arithmetic, etc., etc. So it's also very easy to access the wrong memory, to use a null pointer, dereference it, things like that. And there's also no standard way to handle errors. Yeah, if you open a file, you get a file descriptor as an integer, but that integer can also be negative, which means it was an error, and then you have to go check a global variable called error node to see what the error was. So not fun. So okay, great, C++, right? That's the solution to all the problems from C. Who here likes C++? Okay. Yeah, Ben-Ami, I knew you would raise your hand. So C++ looks fantastic on paper. I thought so too in the 90s, but it's an enormously complex language. It has inscrutable error messages, at least to me. Okay, maybe some of you guys are much smarter than me, but I never understand the error messages. And it includes all of unsafe C inside. You don't have a safe subset of C++. You can still do null pointer dereference or access any piece of memory you want. So it has smart pointers and things like that. It tries to be safe, but it's not enough. So if we look at the diagram of recently popular programming languages, of course we have all these VM-based languages, Java, JavaScript, Scala, which are great, but are not suitable for writing Redis modules. They run on the VM, it's a big platform. Scala, though, did introduce some very interesting things from the functional programming world, and it finally brought functional programming to the real world. I mean, functional programming used to be these Haskell guys. Who here likes Haskell? Nobody. Okay, so probably some of you have heard these Haskell guys talking about monads and functors and things like that. So, okay, great. But for normal people, functional programming used to be unapproachable. So Scala did great work there. And Kotlin, which Mario talked about earlier, is a fantastic language running on the JVM. And the interesting thing is that Kotlin, Rust, TypeScript, Swift, they all look pretty much similar. If you look at source code in all of them, they look very much alike, even though some of them run on bare metal and some run on the VM, on the JVM. And that's because they incorporate ideas from functional programming languages. And they use a strong type system, they use type inference, and they have a functional look and feel. So, as I said, Platonic ideal of programming languages, we're approaching it, and languages are starting to look more and more alike. Okay, show me the code. Let's look at some Rust code. Does it look familiar? Yeah, looks like C to me, right? Yeah, that's because it is C, okay? This is not Rust. So we have a simple C program. We create a structure with a person in it. The person has a name and an age. And then we have a main program. We create an instance of the person called Joe, who is 25 years old. And the important part here is we create a pointer named somebody, which has a reference to this person. It's not a safe reference. It might be null or anything else, but OK, we have a reference. And then we print it. And we do something very interesting here. We do a dereference. We have this arrow operator in C, which means follow the pointer and then give us the field from that struct. If we look at the actual Rust code, the equivalent to the previous C code, it looks pretty similar. The most visible difference is that the order is the other way around. First you have the name of the variable and then the type, as God intended, yes? The C guys thought it was a good idea to put the type first, to not have a keyword for writing functions and not have a keyword for creating variables. Anybody has ever tried to understand the syntax of a function pointer taking a pointer to another function pointer will agree that it was not a great idea. So in Rust, we use first the name of the variable, then the type. And the nice thing is that because we have type inference, the name of the variable might be enough in many cases. So here, if we say let person equal a new instance of person, we don't have to say, like in Java or C++, person, 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 person. And let somebody equals reference to person. Again, the compiler does type inference, and we know that somebody is a reference to person. And the nice thing is, the compiler also does automatic dereferencing for us. Like in Go, we don't have to use the arrow operator. It doesn't matter if it's a pointer or a direct structure. It automatically does the right thing for us. Never mind about that static there. That's too complex to explain. And I32 is just an integer of 32 bits. The default in Rust is for values to be immutable, so we cannot change the age of a person. That's for safety. We don't want somebody to take a variable and change it by mistake. It's also for optimization. We can easily send this value to multiple threads, for example, and be sure that nobody can modify it. And this is part of the safety in Rust, the thread safety. So if we want it to be mutable, we have to say this modifier let mute person. Well, mute person doesn't sound good, but let mutable person. And then we can modify his age. Rust does have generics. They look similar to C++. They also do the same thing as in C++. They write different versions of the code, not like Java where it does type erasure. And this is a built-in structure in the language. It's called vec for vector. Inside it has a buffer and it has a size. So if we want to create a new instance of a vector, we have to create a mutable variable called languages. We say this is a vector that takes references to strings. And then we can push a bunch of strings into this vector, and it will grow. That's nice, but it's not very usable. It's also not very performant, because if we know we're going to push 3 values into the vector, we could have pre-allocated it to side 3. Now, we could write a function to do this for us, but then we have to pass the items to the function somehow. We have to create some intermediate data structure, like an array. It's also not very performant. So what Rust gives us is macros. Well, Loris said macros are a terrible idea. I think that macros are a wonderful idea. There are hygienic macros, very similar to scheme. Again, Rust is not Lisp, the syntax is different. But unlike the C preprocessor, you cannot do weird things in macros like mask built-in identifiers or create new identifiers, but you do get access to the AST. You do get access to the parsed tree of your code at compile time, and you can modify it. And this built-in macro vec simply creates new syntax in the language. It doesn't take an array of 3 items. It creates new syntax. It actually creates, at compile time, the same thing we see here with some additional things inside. So this is very, very powerful. It also lets us create an immutable variable, but I'm not going to talk about that too much. Another wonderful thing in Rust is sum types. Sum types, sometimes they call them algebraic data types, but they're just one kind of algebraic data types. Sum types let us say we have a value which is either this kind or that kind or the third kind, one of a finite set of values. It's similar a bit to union in C. In C we can say, okay, we have either this or that or the other, but unions are one of the most completely unsafe features in C because you can always set one value and then read the other value and then you get complete garbage. It's similar to a variant or a tagged union in some languages that have them. The closest thing you would do in Java, for example, is create a base class and then derive from the base class various subclasses, and then you can have an instance of one of the subclasses. But there's no way to check that nobody is going to add additional subclasses or that you have exhaustively tested all of them. So sometimes solve that. So if we want to, represent a JSON document in Rust, we can define an enum. Enum is the way to define sum types. It's not similar to C enums, which are just glorified integers. An enum says value is either null or bool or number, etc. So it's similar to base class and subclasses. Each of them would be a subclass, but it's a sealed class, like in Kotlin. You cannot add additional values by subclassing. There is no subclassing in Rust. There's no inheritance. One of the greatest things in Rust is there's no inheritance, like in Go. So there is no way to represent an invalid JSON document in this code. The compiler will protect us. The compiler will not make it possible to represent an invalid JSON document. It's like specifying a grammar as a data structure, and this is amazing. And any value can also carry associated data. So for example, null doesn't carry any data, but number has a 64-bit float inside, and we can get it out again. How do we do that? If we combine sum types together with macros, we can create new syntax that lets us create JSON documents in the language. So what we see here is a macro called JSON. Exclamation marks or bangs, they represent macros. So the Json macro creates new syntax. It looks very similar to a dictionary in Python. Yeah, we have a key, which is a string, and a value. This is not normally valid Rust syntax or a JavaScript object notation the same. And this will create instances of the type that we saw on the previous slides from this data at compile time, totally type safe. So it's again impossible to specify an incorrect JSON document that will fail at runtime. And if we combine this with pattern matching, which is the back half of some types, then we can get the values out again. Pattern matching looks a bit like switch statements, but a switch statement just lets us determine which one of several conditions is true. Pattern matching also lets us get at the values. So if, for example, we have value bool, if it's a boolean, then we specify, put it in the variable b. And then we have the variable b, and we can use it to print it or format it to do something else with it. So the pattern matching lets us deconstruct the values that we built. This is, of course, not original to Rust. Rust doesn't try to be original. It just tries to take the best ideas from all languages and put them together into the Platonic ideal, as I said. So pattern matching together with macros and together with some types are some of the best things in Rust, in my opinion. Itamar, do you have time? OK, great. So that's the advantage of being the last one. Yeah?
I have loads of time. Really, just go on.
Captive audience, right? If you want to stay for the reception. If not, feel free. I won't be disappointed. OK, so enough of this. Rust is wonderful or Rust is terrible, whatever you decide. At least try it. It's not too hard to try. It will take you a few days before you start fighting with the borrow checker. And if you get stuck, you'll get through it. So let's see how we can actually write Redis modules in Rust. First of all, there's prior art. I looked at various people who built Redis modules in Rust, and there's a guy called Brandur. He built something in a marathon for Redis, and some of these have very interesting ideas. I try to steal these ideas as much as I can, all open source, of course, and of course the toolkit that I present is also open source. Took some of the ideas, mixed and matched them, added some new ideas with the goal of creating amazing. With the goal of creating a toolkit to make it easy for all of you to write Redis modules in Rust. So, as Laurie said, to write a Redis module, we first have to write all kinds of C-compatible functions. If we want to create a new command, that's one of the most common things. Anybody here has ever written a Redis module? OK, a couple of you. Yeah, Itamar, I think I saw some of your code, yeah. So, we need to, one of the most common things we want to do in a module is add a new command to Redis. So Redis needs to be able to call our function when we give that command. We need to tell it, OK, we have a command named hello. We want you to call our function when that command is received. So we need to define a callback. And that callback, of course, has to follow C calling conventions, because Redis is written in C. And anything has to be linked to it has to use C calling conventions. So Rust was designed to be full duplex compatible with C. Full duplex means it can easily call C code, and it can easily be called by C code without any overhead. So this C function signature means that Redis will call our C function. It will give some internal data structure of Redis called the context, and it will give us a list of strings and an integer saying what length this list of strings is. As you know, in C, there's no way to send a slice or something like that. You have to say, OK, here's a pointer to some characters, and I'm telling you how many there are, but you can easily, of course, overrun that and wreak havoc on all kinds of things. How would it look like in Rust? So the very low-level Rust that's equal to this C code looks like this. It's very similar to what Laura showed in Zig. Again, everybody steals from each other. So we create an extern function. Extern tells this Rust compiler and the linker to be compatible with C. We get a regular C symbol for this function. And the star mute means a mutable raw pointer. This is not something we usually use in Rust. In Rust, we just use references. This is a raw pointer. It's compatible with C. And we can pass it along all we want. That's fine. But we cannot dereference it, because dereferencing a raw pointer is unsafe. It can crash. So here we don't dereference anything, we just pass the pointers that we get from Redis to our function, and we return a C-compatible integer, which can, of course, be a size of an array, or it can be an error code, or we have to guess or look at the documentation or at the source code. If we look back at the C code, a very, very simple function, it will check the length of the arguments, and if it's wrong, it will call this internal Redis function called Redis module wrong arity. That's the geeky way of saying you sent the wrong number of arguments. And this just called the predefined Redis module function, which returns the error to the user. Otherwise, we return OK. So this function returns OK or error. If we would write to the equivalent code in Rust using the CFFI, the foreign function interface, it would look approximately like this. We have the same signature, we check the number of arguments, and then we have this big yellow thing here. What's happening here is we're calling unsafe code. This will not compile. We need to tell the compiler that this block of code is unsafe. And this is the way for us to be able to compile this code, but we have to be careful to audit the code inside the brackets that are unsafe. So as long as we only call pre-existing C functions like from the Redis modules API, there shouldn't be any problem. The only thing is, this is very ugly. If a Rust programmer looks at this, he sees C. I mean, if I want to write C in a Rust disguise, just write C, okay? What I want to do is write Rust that looks like Rust. So how do we handle errors in Rust? If I open a file, as I said in C, we just get some integer and we have to guess, so we can easily forget to check for errors. If we open a file in C++ or in Java, what's going to happen? An exception if something goes wrong, right? And you can always forget to handle an exception, or and it bubbles up to the user. In Java, they thought checked exceptions would be a solution to that, but no, it's not a solution because anything can be a runtime exception as well, so that doesn't work, or didn't work, and Kotlin removed that altogether. In Rust, we neither return an error code nor do we throw an exception. We use a sum type, as I said, the best thing in Rust. The sum type we use is a built-in generic sum type built into the standard library. It's called result. And a result has two values it can have. Any user-specified object can be inside a result. So if we say we have a result that has either a file or an error, which is the signature of the file open method from the Rust standard library, it means that if we run this, we don't get back a file handle. We also don't get back an error code. We get a result, a sum type, and we have to inspect that sum type to see whether we got an error or we have a valid file. How do we expect a sum type? Anybody remembers? Pattern matching. Okay? So this is what result looks like. Either it's OK or error with the respective type inside. And, sorry, we do pattern matching. We cannot use it without pattern matching of some kind. We pattern match the result from file open. It can either be OK, and then we get the file descriptor inside this variable named file, and we can use it. Or it failed, and we got an error, and then we can print the error or propagate it or do anything else. Errors are just values. Very, very simple. The Go guys thought they understood this, that errors are just values, but they missed the point that functions in Go return both values and errors, and you still have to remember to check the error. You can easily use the value without checking the error, so what's the point? But that's how it is. So in Rust, it's impossible to ignore. So going back to the C equivalent that we saw, in Rust, we would like to write a Redis command like this. We would like to use the type-safe context, which is just a safe reference, not a raw pointer. We would like to pass a vector of strings as the arguments instead of a pointer plus a counter. And we also would like to return a result, which can either be a Redis value or a Redis error. A Redis value will serialize the correct data with the Redis protocol, and a Redis error will send an error message to the user. It should be transparent and easy for me as somebody who writes a module. The problem is, yeah, and this is how it would look, how we would use it. We can either return an error with the wrong arity wrapped inside, or we can use return OK with the Redis value wrapped inside. The problem is that as a programmer, I need to write lots of boilerplate code because I want to write these idiomatic Rust functions. But I need something that wraps each Rust function and creates the C-compatible wrapper for Redis to call. Redis cannot call my Rust function directly because it's not C-compatible. It's not an extern function. It's a pure Rust function. So we need to write an extern C function for every Rust function, which kind of defeats the purpose of keeping it simple. And we also need to convert the arguments and the return value to a vector and back. It looks like if we want something nice, we're going to have to do lots of work. So macros to the rescue. We can define a Redis command macro that does all this boilerplate work for us, because that's what macros are meant for, doing boilerplate work. So I can just say Redis command, give it the context, the name of the command, and the pure Rust function, and some flags. And it will take the function. It will automatically, at compile time, write a C wrapper function for it and do anything that's needed. And we can create an additional macro called Redis module that calls the necessary setup functions. For example, every Redis module, as Loris mentioned, needs to call a Redis module on load, and there's also Redis module init, and there's all kinds of boilerplate stuff we need to do. We can hide all this stuff inside a Redis module macro that will do the boilerplate for setting up the module, and it will also call the Redis command macro. Macros can be recursive to set up all the commands that we want to define. So this is how an entire Redis module looks like in Rust. I did not cheat here. The only thing I removed was the imports, but otherwise this is a complete Redis module. What it does is it defines a pure Rust function called hello that gets the Redis context and a list of arguments, and it returns a result, which can either be a Redis value or an error. The second line, let key, I won't go into the syntax here, but this is one of the idiomatic ways to use iterators in Rust to get the next argument from this vector of arguments. And finally, I return OK, greeting. The magic trick here is the question mark you see here high above. What this question mark does is it hides lots and lots and lots of boilerplate behind it, a special syntax in the language, which automatically takes care of unwrapping the possible result that we get, and if it's an error, returning it to the caller, and if not, continuing. It's very interesting, but we won't go into it here. And the into also is a standard idiom in Rust, which lets us define converters from one data type to another. So we just create a string, and the into will call the converter to convert it automatically to the Redis value. And finally, here's the macro, Redis module. This looks like native syntax in the language. It looks like we're defining a struct or something like that, but we don't. This is special syntax that we introduced. We say the name of the module, version, and we give it a list of commands. And this will do all the magic at compile time again, and we will have an entire Redis module ready. Here's how we use it. We go to the Redis CLI, we say module load libhello.so or dilib, or depending on your operating system. We say hello. It says, sorry, you're missing the argument. Wrong arity, just returns the standard Redis error message. And if we give it the correct value, it's great. It gives us a greeting. So that's it. The code is open source. It's on the internet. You can check it out. It's work in progress. If anybody would like to contribute, I would love to hear from you. Here's my contact info. Thank you.